ELR 1.9 is about converting units in the metric system. The metric system, I'm sure, is something that you have seen before, but maybe haven't done a whole lot of converting with it because our country in general uses things like miles and gallons, and those are considered to be the English system. But in science, all over the world, it doesn't matter what country you're in, we use the metric system to measure things. So whether you're measuring temperature or volume or mass or length, distance, all of the things that can be measured, we have a special system called the metric system. So let's talk about how it actually works. You may have noticed this little table up on the wall above my doorway in the classroom. This King Henry died unexpectedly drinking chocolate milk thing, that's just a way to remember this, and you don't have to memorize anything. It's just a fun way to spell it out. Well, each of the letters, the K, the H, the D, the U, the D again, the C, and the M, each of those are the parts of the metric system. So let's start in the middle. The U stands for unit. So whether you're talking about distances, those might be liters. If you're talking about, those would be meters. If you're talking about volumes, like how much space something takes up, that would be liters. How much mass something has, that would be grams. And everything else that is measurable in science has its unit. We can use the metric system with anything measurable. So if we have meters and we want to convert that to another unit, maybe like centimeters or millimeters or kilometers, all that we need to do is move some decimal places. I think it's best to start with an example. So you have this one on your paper too. So let's say that we have an object that is 15 meters long. So this is about a meter, 15 meters long. It's pretty long. What if we need to know how long that is in kilometers? Well, the metric system makes this pretty easy. The first step is to figure out, well, where is the decimal point? Sometimes you're given a number where it's just written in there. If you have the number 15, it's right after the number. So 15 dot, decimal place is right after the number. Then we need to decide, do we need to move that decimal to the right or the left? Well, that's where this table comes in handy. So right now we're starting at meters, and meters is right here under the U. And we need to get to kilometers. So that's the K for kilometers, for king. Well, we need to go 1, 2, 3 spots over. We need to move our finger 3 places in order to get to kilo. So that tells us how many spots to move the decimal. We're going to go to the left 3 spots. Well, now we just write it in there. So let's get my number. I'm going to take 15. I'm going to swoop that decimal spot over 3 times. You might have noticed that now we have an open gap right here. Well, we just fill that open gap with a 0. So our answer is 0.015 kilometers. Also in science, a lot of scientists don't like to leave a decimal place without numbers on either side because sometimes if it's written in a sentence, it can look like the period for the previous words. So we like to put a leading 0 in front of it. But all we did was move the decimal 3 spots over. Let's try this one. Let's say that we want to convert 156.7 milliliters and we want to know how much is that in kiloliters. Just so you have an idea, this is a graduated cylinder. I think you've used these before. This holds 100 milliliters, so it would be 1 and about a half. So we're talking about 1 and a half of these things. We want to know how much is that in kiloliters. So we're not changing the amount of stuff. We just want to know how much is it if we measured it using another system, kilo. So we do the exact same steps. Where is the decimal place? Well, there it is, right there. It's just written right in the number this time. We need to decide, are we moving right or left? Well, now we're starting way over here on milliliters, where milk is, and we're going all the way over to the other side where K is for kilo. So we're going left. We're going 6 spots this time. So there's going to be a lot of movement. So now we start adding in, or swooping our decimal. That's 1 swoop. There's 2, 3, 4, 5, and 6 spots over. Then we just fill in all those spots with zeros, and we have our number. 0.000156 kiloliters. Remember, we didn't change how much stuff. That's still about 1 and a half of these. But if you're going to measure with a big thing like a kiloliter, that's how you might measure like swimming pools. Well, that's not very much liquid, So hopefully it makes sense that it's kind of a tiny number now. One more practice one. This one I would like you to try on your own. I need to know which is bigger, 67.8 meters or 512 centimeters. Please pause and try that now. If you're still watching, you have tried that question that's on the screen. In order to answer this kind of a question, we need to convert one of them into the other. So we can either turn this number into centimeters or turn this number into meters so that we can compare them. I just chose to do this one, the 67.8, and I decided to turn it into centimeters. So the steps are just the same as before. Here's my decimal between the 7 and the 8, and if I'm going from meters to centimeters, here's meters in the middle, centimeters is under the chocolate. We're going to go 2 spots to the right. When I do that, I'm going to move it one over, add a 0, I'll get 6,780 centimeters. Well, that number is definitely bigger than 512. So 67.8 meters is the bigger one. So let's review really quick. A unit is just a way to count something. So let's say that you are counting the number of students. Well, students is a unit because it's a way you're counting something. We could have kilo students and millistudents and centis students. We can put all of those metric prefixes in front of any unit. So I want you to count how many students are in this class. I counted, let's say that in my class I had 26. You should have a number on your blank too. Well, if student was a unit, let's figure out how many millistudents are in this class. In order to get to millistudents, I have to swoop the decimal 3 spots over. So I would have 26,000 millistudents. Remember, that's the same number of people. I haven't changed how many people are in the room. It's just another way to measure it. Like if you were to chop up some students, which would be horrible, but that's how many millistudents we have. Well, what if we go the other direction? How many kilo students are in this class? Well, kilo is 3 swoops to the other way, so we would have 0.026 kilo students. But all 3 of these numbers are the same amount of student, just different ways to count them. So maybe think about how much kilo homework did you get assigned today? You could go home and really brag about how much kilo homework you got done because it might sound like it's a big deal. Now it is time to pause the video, and I need you to do the leveled practice that's on your screen. The green questions are the easier ones, then the yellow gets a little bit tougher, and the red one is the hardest. I need for you to make sure that you are going and checking your answers on the front counter before you move on to following questions. So you're going to do number 1, 2, 3, and 4 on your paper. Then go check your answers to the green section. Oops. Go check your answers to the green section before you move on. Pause this video on these questions. Check your answers in between each section.